Good day everyone, my name is Alia and today I will present about UV-Vis Spectrophotometry experiment. So in this experiment, I will explain the Beer-Lambert law, determination of lambda max, construction of the calibration curve, and calculation of unknown concentration. So the objective of this experiment is to understand the principle of UV-Vis spectrophotometry, identify the wavelength of maximum absorbance, which is lambda max, construct a calibration curve using standard solution, and determine the concentration of unknown sample. So, this experiment is based on the Beer-Lambert law. This equation is A equals to epsilon L times C, where A represents absorbance, epsilon is molar absorptivity, L is the path length of the cuvette, and C is the concentration. The Beer-Lambert law states that absorbance is directly proportional to concentration. This means when concentration increases, absorbance also increases. In this experiment, standard solution will analyze using a UV-Vis spectrophotometer. Absorbance reading will measure at 3 different wavelengths, which are 610 nanometers, 620 nanometers, and 630 nanometers. The purpose of testing different wavelengths was to determine the wavelength that gives the highest absorbance value for the analyte. From the result obtained, absorbance increased as the wavelength approached to 630 nanometers. Therefore, we can conclude that 630 nanometers was identified as the lambda max for this analyte. Lambda max is very important because it gives the highest absorbance and maximum sensitivity. Measuring at this wavelength improves the accuracy and reliability of the analysis. A calibration curve was then constructed using the absorbance values at 630 nanometers, and the linear regression equation obtained is y equal to 2.502 x plus 0.0004. The R-square value is 1, which indicates a perfect linear relationship, concentration, and absorbance. This confirms that Beer-Lambert law is obeyed within the tested concentration range. Using the calibration curve equation, the concentration of the unknown sample was calculated. Unknown A was determined to be 0.18 mole per liter. Unknown B was calculated at 0.352 mole per liter. Lastly, unknown C was found to be 0.48 mole per liter. This concentration was obtained by substituting the absorbance value into the calibration equation. So, there are several possible sources of error in this experiment. These include pipetting inaccuracies during dilution preparation, contamination or fingerprints on the cuvette surface, and stray light entering this instrument. Another limitation occurs when concentrations become too high. At high concentration, the Beer-Lambert law may no longer be followed, causing the calibration curve to become nonlinear. In conclusion, the experiment successfully demonstrated the principles of UV-Vis spectrophotometry. The wavelength of maximum absorbance was identified as 630 nanometers, and the calibration curve showed excellent linearity with an R-square value as 1. The concentration of the unknown samples were also successfully determined using the Beer-Lambert law.